All right, today's topic is talking about collecting sample data. Now, our key concept today is that when you are analyzing your sample data, it's essential that you use appropriate methods for collecting these sample data. Collection is key here. And of the one really important thing we're going to talk about is a simple random sample. Very important that you know how to collect a simple random sample. If your sample data is not collected in an appropriate way, your data will be completely and utterly useless, and it's not even, people are going to tear apart your study. So that's very important. First step, collecting the data correctly. That's really what we're going to focus on today. All right, so the gold standard is called randomness. We want data to be completely random. If you are if you're doing a medical trial, and I'm going to use this a lot because they have to be the gold standard when it comes to studies. We will have placebo groups and treatment groups. And this is considered the gold standard because people don't know if they're going to be getting the drug or not. If they get the placebo, they're usually getting sugar water, saline, like it just depends, a pill that's just sugar, they don't know, versus the group that's actually getting the medication. Because we don't want people to know if they're getting the drug or not. And the placebo is not going to hurt anybody if we give it to them. But please note that placebo can have psychological effects where people think they're getting the drug, so then they get better because they think they're getting better. And there's a lot of research about how the mind has the ability to do that, to create a better end result. This happens a lot with cancer patients. Cancer patients who are religious are actually found to have better recovery rates than cancer patients who are not religious. So interesting stuff. But as far as the medical side goes, not the psychological side, the medical side, the placebo has no medical effect at all on the results that we're going to get. Psychological, that's a whole other story. We can talk about that another day. All right, so the basics of collecting data. So how do we collect it? There are different ways that we can. If we're doing an experiment, we're going to do some kind of treatment, and then we're going to observe what happens. Whether that's watching how people react, whether it's, so we call the people that we're watching subjects. It sounds very dehumanizing, but we call them subjects. And it could not just be humans, it could be dogs, it could be chimpanzees, it could be all kinds of things. So we call those the subjects. And each individual subject is called the experimental unit. Again, very dehumanizing, but we have to kind of keep a distance from our subjects when we're doing an experiment. An observational study would just be us watching and observing and measuring things without attempting in any way to modify our subject's behavior. We want to make sure that we are not inserting ourselves into this experiment, that we are solely just standing back and watching and doing nothing. I often call this the National Geographic effect because I don't know about you, but if you've ever watched a nature documentary where they watch like a seal get eaten by an orca, and I'm like, I just don't know if I could. I don't know if I could just sit back and watch the poor seal get eaten by the orca. It's a circle of life thing, I know. But I would have a very hard time with an observational study like that, where my actions could make a difference. So observational studies, you are not getting involved. I have a really good observational study to talk about that has to do with ice cream and drownings. We'll talk about that in a second. But if we just look at data without any context, I can show you data that shows that as ice cream sales increase, drownings increase. So does that mean that ice cream sales are causing the drownings? Obviously not. So you want to make sure that you're not just taking everything at face value. Okay, what do ice cream sales and drownings have in common? Ice cream sales usually increase when it's warm outside. Drownings usually increase when it's warm outside because more people are going swimming. So it's the temperature that's actually what you should be looking at, not the ice cream sales. So again, you have to be careful about those lurking variables. Sometimes we call them confounding variables that could be lurking in the background. And our experiment is we just looked at people who bought ice cream and then if those people drowned in the future or not. And if they bought ice cream, if they didn't buy ice cream, did they not drown? Did they drown? We don't know. So again, obviously this study is a little bit flawed, obviously, because we're kind of looking at the wrong variables. But this still could be your experiment. It still would be a valid experiment. So I found some similar setups that I thought were interesting. So the first one is that if you look at the letters in the winning word of the Scripps Spelling Bee that happens every year, and the number of killed by venomous spiders every year, look at how close those curves are. Okay, does that mean that the number of letters in the winning word is going to define how many people die from venomous spiders? Obviously not. They're not even connected. There's no connection between the two. But we could show that there is a correlation between the two. So you will often hear people say, correlation is not causation. You'll hear that a lot in statistics. Just because two things happen at the same time, just because they correlate, doesn't mean that they cause each other. So we have to be careful about that. And then my favorite one is that the number of movies that Nicolas Cage appears in every year versus the number of drownings that year. Okay, does Nicolas Cage appearing in a film mean that somebody's going to drown? Absolutely not. There is no causation going on here, but there is a correlation, which I think is interesting. So maybe Nick Cage should just stop making movies and then we wouldn't have anybody drowning. Is that how that works? No, not really. All right, so when you are designing experiments, it's really important that other people be able to replicate your results. If you conduct an experiment and no one else is able to replicate your experiment with the same results, then there is something very flawed with your experiment. And that's very important. I often see people, especially on Twitter, saying, oh, look, I saw this study. Well, that one study couldn't be replicated, so is it valid? Not really. If you're able to replicate, that's actually a better sign that your data is solid, because if other people can replicate it and get the same results that you did, then you are spot on. Blinding is a technique that we do in experiments that's kind of funny. Go back to those medical ones. If they got the placebo or not, we don't know. And sometimes they even have it labeled so that the medical professionals giving the drugs don't even know. They're not allowed. There's only one person who's going to know whether it's what subject is getting the placebo and what subject is getting the actual medication. So blinding is another way to make sure, because maybe the nurse may treat you differently as she's handing you the drug if she knows it's a placebo versus knowing it's the medication, right? Maybe the medical professionals will treat you differently because they know you're getting the placebo. So they make sure that no one, not the subject, not the people involved, know what's going on. That's called blinding. Very important. Double blinding. And this is, again, I kind of walked into that one. The double blinding is where everybody doesn't know. The experimenter doesn't know. And there are ways that you can actually do that where even you, who is running the experiment, doesn't know who's getting what. You could have a computer do it, and the computer assigns. And then they have computers that will spit out the drugs for each person, and you have no idea until the experiment is completely over. So it's really important that we don't let our knowledge of the experiment change our behaviors towards the subjects. And then there's randomization, which is where your subjects are assigned completely random. Just put names in a hat and you draw them out. So especially if you're putting people in groups, you just draw a name, you're in group A. Second name, you're in group B. Third name, you're in group C. That's really important because you want to make sure that you don't have two groups that are completely identical in makeup. So you got to make sure that you have some randomness that occurs when you're talking about those groups. All right, so now we can get to the real guts here. Simple random samples. All right, so when we talk about sample size, we always use the letter n. Lowercase n is our number of subjects. And we want to make sure that every single person who is in our sample, no matter what number they are, subject number 1 or subject number n, that they have an equal chance of being chosen. Okay? That they have exactly the same chance. Doesn't matter who they are. First subject, last subject, doesn't matter. And a simple random sample is just a random sample that has a weaker requirement, that they all have that same chance. So you really want to make sure that you truly have these simple random samples. Everybody is equally likely of getting the placebo, and everybody is equally likely of getting the actual drug. So very important that we have that simple random sample. There's other ways that you can sample, and that just depends on what you're doing. So like if you're doing a phone-in, like if I want to sample of everybody here at the college, I'm going to say, or the school, I'm going to say, okay, I'm going to just print out a list of every single person who goes to school here, works here, and I'm going to call every third person. So like here they used cars. So the third car, the sixth car, the ninth car. So I'm not going to call every single person. I'm just going to call every third person on the list, or just select every third car in the parking lot, whatever the case may be. Systematic sampling works pretty well that way, because when you put people in alphabetical order, do you know who you're going to get? No, not really, especially if you've got a large organization. Convenience sampling. You have to be careful with this one because this can lead to bias. It's just where I'm going to go and ask a survey questions, and I'm going to go someplace where I know a lot of people are going to be, right? Like if you go to the Walmart on a Saturday, there's going to be a ton of people there, so you can get a ton of data. And it's convenient because you go to one spot and you sit there with your clipboard and you just ask people. Now, could that data be biased? Absolutely. So it's on a Saturday, which means you're not going to get people who work weekends, which there's a lot of people who work weekends. You're going to get people who don't shop at Walmart, right? If people don't shop at Walmart, you're never going to get their data. So you got to make sure that you're really careful with your convenience sampling. Stratified sampling is where you're going to divide your population into two subgroups and then choose from those two subgroups, choose your subjects. So like if you have men and women, you're going to choose 3 men and 3 women randomly from each group. You wouldn't want to put them all together, because if you just chose randomly, then you might end up with more men than more women, or more women than more men. So you divide them first and then choose equally from each of those subgroups to make sure that you have gotten all your subgroups. And those subgroups are sometimes called strata or stratum, plural versus singular. So you might also hear those words used when it comes to statistics. And then you've got cluster sampling. Cluster sampling happens a lot, especially when you're doing like polling in political. You're going to canvass a certain area of the neighborhood, and you're just going to pick certain blocks, because obviously you couldn't go to every single house in the entire single neighborhood. So you're going to divide the area into little clusters, like maybe city blocks like they have in this example, and you're only going to go to those city blocks and poll those certain people. And you may choose those by random, which would actually be great, because then you're not, again, showing bias. You want to make sure that at all times when you're collecting data, you're not showing bias. So if you just randomly choose different city blocks, just number them and then choose numbers out of a hat, then you're going to be sure that you're not, having any bias on which ones that you're collecting. And then you've got multi-stage sampling, where you do multiple things. So maybe you do convenience polling, but you also divide into subgroups, and then you randomly choose from the people who did, and then who filled. So say you did men versus women, and then you took all the men's and you randomly chose 100 of those, and then you look at the women and you randomly chose 100 of those, right? So you kind of do multiple things. So you do convenience and your convenience sampling, but you also do, your stratified sampling as well by putting into subgroups. So you could do multiple things in your sampling as well. So that's just a kind of quick overview of all the different ways that we can sample. And hopefully I will see you next time.